Hi everybody, in this video let's look at matrices. A matrix is a rectangular array of number, we call it elements, enclosed in a large bracket. Actually, it not necessarily need to be number, it can be words, it can be symbol, and so on. But in this video, we will just focus on the matrix with the element which are number. Okay, so this all number we call it element, or we can call it entry. Normally, we represent a matrix by using a capital letters. For example, if I want to represent this matrix, right, I can just use A is equal to 2, 4, -3, 9. You can use this round bracket, or you can also use a square bracket. These both are correct. You just follow your school teachers. Okay, now you know that we can represent a matrix by using a capital letter, right? Normally we do it like this. And how do we tell people that the element, how do we represent the element of a matrix? If this is A, we will represent the element of this matrix by using a small letters of these letters. So I will use small letters of A to represent the element here. If I just write A, people don't understand that or don't know which element we are talking about. That's why you see two tiny numbers here, I and J. I is a number of row, J is a number of column. For example, if I write A21, then people know that which element you are talking about. Second row, first column. Second row, first column. Okay, so this element is actually -3. Okay, let's try another one. A12. It means that first row, second column. First row, second column, which is 4. Okay, so this is a way how do we tell people which element we are talking about. So you can just refer here. 3, it means that the third row, third column. 2, second row, second column. 2, second row, third column. Okay. Next thing, we are going to learn how do we state the order of a matrix. When we want to state the order of a matrix, we need to mention two things, the number of row and the number of column. Okay, let's try these few matrices. How many rows do we have here? 2 rows, right? 2 rows. How many columns? 2 columns. So the order of this matrix will be 2 by 2. When we state the order of a matrix, we need to mention the number of rows first, then followed by the number of columns. Okay, now let's try the second one. How many rows do we have here? 1, 2, 3. 3 rows. How many columns? 1, 2, 3. 3 columns. So the order of this matrix will be, remember, state the number of rows first, followed by the number of columns, 3 by 3. Okay, let's try the last one. How many rows do we have here? 1, 2. 2 rows. How many columns? 1, 2, 3. 3 columns. Okay, so the order of this matrix will be 2 by 3. This is the way how we state the order of a matrix. Okay, next, let's go to learn a few terminologies that you are going to see in these chapters. Row matrix. A row matrix, it means that the matrix which only has one row. Okay, one row. So, for example, now we have two elements here. If I want you to state the order of this matrix, it will be 1 by 2, one row. So this matrix, we call it row matrix. Okay, so how about column matrix? Column matrix is a matrix which only has one column. Okay, and next, square matrix. Square matrix, it means that the number of row and the number of column are equal. It can be 1 by 1, 2 by 2, 3 by 3, 4 by 4, and so on. Okay, last one, rectangular matrix. It means that the number of row and the number of column are different. You see a rectangle here. So this is 2 by 3. Okay, now let's try a few examples for this part. Example number 2. We want to state the number of row and the number of column and the orders of each of the following matrices. How many rows do we have here? One row, right? The number of row is one row. How many columns do we have here? 2 columns. So the order will be 1 by 2. Always remember, state the number of rows first, followed by the number of columns. How about this one? 1, 2, 3. 3 rows. How many columns? 1, 2, 2 columns. Therefore, the order will be 3 by 2. Okay. So this is a row matrix because this matrix only has one row. Oh, sorry. This is a column matrix because this matrix only has one column. We have 3 rows, 1 column. Okay, so the order will be 3 by 1. If there's only one column matrix. If there's only one row matrix. Okay. How about this? How many rows do we have here? 1, 2. 2 rows. How many columns? 1, 2, 3. 3 columns. So the order will be 2 by 3. So this is the way how we state the order of a matrix. Okay, now let's try another example. Given the matrix A, okay, let me copy it down first. A is equal to 3, 2, 4, -5, 9, 5. Okay, so we want to find each of the following value. We want to find the elements, state the element of A13. Okay, so A13. When you see this small tiny number 1 and 3, you know that the element is at first row and third column, right? First row, third column. From here we know that this element is equal to 4. Okay, so let's try the second one. A23. 23, it means that second row, third column. First row, second row. First column, second column, third column. So you see the cross is over here, right? This element is 5. Okay. How about C? Okay, I write over here. A, this is 2, 1. 2, 1. plus 6A 1 1. Okay, 2 1 second row first column, second row. Okay, let me draw the line for you, easier for you to see it. Second row first column, -5 plus 6 times this element, first row first column, first row first column. Okay, so this is actually 3. -5 plus 18, so it will be 13. Okay, now let's try an example. Example number 4. Given that A is equal to 2x, y plus 3, -2, these all are the elements of this matrix A, 4, 5, and 3. Find the value of x if A11 is equal to A21. A11 is equal to A21. 1, 1, it means that first row, first column. First row, first column. Can you see the cross is over here, right? So this is 2x. Okay, so 2, 1, second row, first column, second row, first column. 4. Okay, until here, I think it should be no problem. 2x is equal to 4. X is equal to 4 divided by 2, which is equal to 2. Now let's try part B. A12 plus A13 is equal to 2 times A23. So if you know how to determine the element represented by A12, A13, and A23, then you should be no problem to solve this one. A12, it means that first row, second column, which is y plus 3. Y plus 3. Okay, so this one is for this. Plus A13. 1, 3, it means that the 1 tell you first row. The 3 tell you third column. First, second, third. So this element is actually -2. Okay, so 2 times A23. Which one is 2, 3? The 2 tell you second row. The 3 tell you third column. 1, 2, 3, third column. 3. Okay, once you have written all this number down, I think it should be no problem to find the value of y, right? Okay, so y plus 3, positive, negative, will become negative. And 2 times 3, we will get 6. Positive 3 minus 2, you get 1. Okay. Y is equal to 6 minus 1, which is equal to 5. Next example. In this example, we are talking about the equal matrix. So, what is this and what are equal matrix? Let me go back to the note. Two matrices are equal if and only if they have the same order and their corresponding elements are equal. We have two conditions here, same order and the corresponding elements are equal. Okay, now let's try this example. Determine whether the following pair of matrices are equal. Okay. Order, this is 2 by 2, right? 2 row, 2 column. So here is 2 by 2, 2 row, 2 column, same order. But same order is not enough. We have to look at their corresponding element. What is meant by corresponding element? The corresponding element of 0 will be this. The corresponding element of -4 will be this. The corresponding element of 9 will be this. So you will notice that these and these are not equal, right? Even though they have the same order, but the corresponding elements are not the same, are not equal. Therefore, A is not equal to B. They are not equal matrices. Okay, the question asks you to give your reason. So I already told you the reason, which because of -4 is not equal to 4. You can write this way, because how to mention this element? First row, second column, right? A 1 2, which is -4, is not equal to B 1 2. Corresponding element, they are not equal. That's why they are not equal matrices. Okay, now let's go to B. C, the order is 3 by 2. 3 by 2. The order here is 2 by 3. Since they don't have the same order, then we know that C is not equal to D, because their order are not the same. Okay, so the explanation, the give a reason, you can just write because their order are not the same. The order of matrix C is 3 by 2, whereas the order of matrix D is 2 by 3. Okay, now let's try part C. First, we look at their order. 2 by 2. 2 by 2. How about this? Same thing, 2 by 2. Next, we go to their corresponding element, whether they have the same corresponding element or not. You might be thinking 0.5 and 1 over 2 teacher, not the same, right? -2, 4, and -6 over 3, not the same. But they actually equal to each other. 0.5, same value as 1 over 2. -2, same value of -6 over 3. And here the same thing, 7 equal to 7. 0.3 is actually same value as 3 over 10, right? So they have the same order, and also their corresponding element are equal. Therefore, A is equal to, not A, E is equal to F. They are equal matrices. Okay, let's go to the last example that I'm going to discuss with you in this video. If, not if, this is typing error, it is given that matrix P is equal to this and matrix Q is equal to this, and we have few unknown here, Y and X and Y. Determine the value of X, Y, and Z. Okay, we have another Z over here. We want to determine the value of X, Y, and Z if P is equal to Q. That means P and Q are a pair of equal matrices. P is equal to Q. It means that this is equal to this. 2x, Z, 3, 5y is equal to Q. Let me copy down. 3y plus 18. And we have 5 over here. 3, and the last one is 2 minus 2x. Okay, same order, right? 2 by 2, 2 by 2. And their corresponding element must be equal as well, if they are equal matrix. Okay, so 2x is equal to this. Z is very easy, we know. We don't have to calculate right away, just by looking at it, compare to both sides. Z is equal to 5. Okay, this is the first one that we can get just by looking on it. And the second thing, 2x is equal to this. 2x is equal to 3y plus 18. So we have one equation here. And another one is 5y. Okay, let me write on the side. 5y is equal to 2 minus 2x. So now you notice that you have two unknowns here, x and y, x and y. We know that we have to solve them simultaneously, right? So how about I rearrange all these terms nicely first. 2x minus, I bring the 3y over here, become minus. Is equal to 18. Okay, let this one be the first equation. And here I do the same thing. I arrange nicely x and y. Bring the negative 2x over here, it becomes positive 2x. And you don't have any sign here, it means positive. Okay, just copy the 2. Now you have the second equation. The next thing is to solve them simultaneously. I just copy this over here. Easier for me to solve it. Negative 3y is equal to 18. Okay, this is the first equation. So the next thing is to eliminate one of them. So for this type of equation, simultaneous linear equation, if you don't want to use the elimination method, you can use substitution method as well. Just use the method that you are more familiar to. Okay, here I will show you how to use elimination method to solve this one. So I noticed that here is 2x, here is another 2x. I can eliminate the 2x easily, right? So I just take second minus the first one. So some students might be thinking, teachers, why I need to take 2 minus the first one? Can I use first one minus the second one? Yes, you can do the other way, 1 minus 2, the first equation minus the second equation. Up to you, as long as the 2x can be eliminated. Okay, this minus this, 2x minus 2x. We have no more x. We have successfully eliminated the 2x. And then when you have a negative, you have to be more careful. 5y minus negative 3y. So eventually, negative negative will give you positive. It means that 5y plus 3y, which is equal to 8y. Okay, just be more careful every time you see a negative sign. So this is 8y. 2 minus 18, you get negative 16. If you are not sure, you can just use a calculator. Y is equal to negative 16 minus 8. So y is equal to negative 2. Okay, so once we have the value of y, then it will be easier for us to find the value of x. I write over here. Substitute y equal to negative 2 into which one? You can choose which one you like, 1 or 2. So how about I choose the second one? Substitutes y equal to negative 2 into the second equation. 2x plus 5y, y, right? But now we know that the y is actually equal to negative 2. I write negative 2. So it's equal to 2. 2x. Positive 5 times negative 2 will give you negative 10. Negative 10, you move it another side, it becomes positive. Oh. 2x is equal to 12. And x is equal to 12 divided by 2. X is equal to 6. Okay, so sometimes if you are not confident with the simultaneous linear equation, you can actually use your calculator to help you to solve it. So first, you press your calculator menu, then you choose for equation. This one, equation, then enter simultaneous equation. Press the first one, and the calculator will ask you how many unknown do we have. We have two unknown here, x and y. We press 2. Okay, so make sure you arrange nicely x, y, and the number on another side. Okay, 2, 5, 2. 2, 5, 2. Okay, the second equation is 2, negative 3, 18. 2, negative 3, 18. Okay, let me double check, correct? Okay, so then you press equal again, you will get the answer x is equal to 6, and then press equal, x is equal to -2. It's good that you write down the answer first, x is equal to 6, y is equal to -2. If, let's say, this is not equal, the answer that you got here is not equal to the answer given by the calculator, then you know that there must be something wrong here. So you don't continue. If you continue to do it, you get the same, you get the wrong answer as well. Okay, so you can always use your calculator to help you to solve the simultaneous linear equation. Okay, for this video I stop here first. See you next time. Thanks for watching. Bye bye.